So today we're going to learn on one of the feature extraction called color histogram. We now finish at the deep learning. Today we're going to learn on color histogram. So for image retrieval, so I specifically use the term image retrieval here. Okay, simply because of mostly they use this for image retrieval. You can use for other purpose as well, image recognition and so on. And so if you have features, okay, features of the data. So in images, you got pixel features, you got color histogram features, you got text features for the image. So now color histogram is one of it. Okay. So I think the two word here. One is histogram. This is histogram. Okay. This is histogram. What you see is a histogram. Okay. So another word is color. Okay. So color mean that this histogram is about color. The histogram about color. Simply like that. Color histogram means simply like that. Okay. The histogram, but you can put histogram on anything. And today we put the histogram on color of the image. And we focus on image. Okay. That's the easiest way, okay, to understand this color histogram. So I hope you don't get confused don't panic with the term. You just go to the term. When you say histogram, mean histogram. When it color, so this is histogram about the color. So in this case, image. So this is a histogram of the image on color. Okay. So the color histogram of the image is supposed to be like this. Okay. And so what is the color histogram basically? So color histogram basically is the histogram of number of pixels that has the same color. So you got image like this, say 2 by 2, resolution 2 by 2. So you got 4 pixels. Okay, 4 pixels. And the histogram of number of pixels that has the same color. So you just plot this pixel that has the same color of all the images. So let's look on this. Okay, example. So we got a, let's say, binary. When said binary means 0 and 1. Okay, so in this case is 1 bit, okay? Because you got one seed here. So 1 bit. 1 bit binary image. So 1 bit binary image, you got 2 by 2. Okay? So 1 binary image, 2 by 2. Okay? So bit depth is 1 bit. So in this case, you got like this. So color histogram basically is a histogram of numbers of pixels that has the same color. So in this case, you got between 0 and 1. Okay, so the pixel will contain 0 and 1. So basically, color histogram is defined as a histogram of number of pixels that has the same color. So now you see there. So you got 3 pixels that has value 0, 1, 2, 3. And you got 1 pixel has value 1. Okay, so 1 you got 1 and 0 you got 3. Okay, so color histogram is defined as histogram number of pixels that has the same color. So this one 0, 0 and 0 is the same color, black, and 1 is another one color, white, black and white. Right, and then you can just simply plot like this. Okay, so this is easiest way, easiest example of color histogram. So you can see this is histogram, and you can see the x-axis. So this is x-axis. The x-axis, you got number of color. In this case, you got 0 and 1. Okay, Either you got 0 and 1 because it is 1 bit. So 1 bit you have 2 different color, either 0 or 1. So you got x-axis is number of color of that image, total number of color, and y-axis basically is the count. How many 0 here? So you got 3. 1, 2, 3. So you got 3 there. Okay. So pixel 0, which is black, has 3 pixel. So this is pixel. Number of pixel. So pixels here. Number of pixels. And this is the color. Okay. I think it's quite straightforward here. This is a simple example of a color histogram. Okay, so you can create by Python or by any language, programming language. Go to every pixel, and put some array there, count it. Okay, so this example. So color histogram basically, if you got like this is gray scale. 8-bit, for example. Now you got the histogram number of pixels that has the same color. So in this case, you have to look at how many column and how many row. So in this case, I don't know, probably 10 by 10 or something like that. 10 times 10 is 100. So you got 100 and more here. Okay, and then here you got number of color, which is 8-bit, mean 0 to 254. Okay, 0 to 54 consists of 255 type of color. Then you just plot number of pixels appear here. In this case, if you got black, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and so on. Okay, that's basically color histogram. The definition of color histogram. And so in sometime you face the definition of color histogram in this kind of thing. Okay. Set of bins mean x-axis, where each bin denote the probability of pixel in the image being particular color. So in this case, you got 1, 2, 3, 4 until n. So n here basically depends on number of color. If you got 8-bit, here mean 254. If you got 2 bits, 1 bit, 0 and 1. Okay. And so on. If you got 2 bit, 4, 0 to 3, n become 3. So you got number of, this is called bin. Bin is one particular, okay. In this case, bin basically, so this is 2 bin, 1 bin and second bin. This is just about a term, okay. You can say bin, you can say whatever, a column. So in this case, you call bin. So in books, normally the definition, they normally call it bin. In any paper, they call it bin. So you got bins, and each bin has the number of color, where I represent a color in color histogram and correspond to subcube of RGB color space. Okay. In that image, and n is the number of bin in color histogram. So if you look at the comparing the image similarity, you can use a color histogram to compare. So in this case, you got 2 images A and B. We want to check the similarity between image. When we call similarity, mean how similar it is between image A and image B. Are they both are similar? Okay, or are different images. So in this case, basically, how computer determine is just using the color histogram. That's the easiest way people do it in order to compare two images. So how they use a color histogram in comparing these images? Anyone? So are these two images identical? Yes or no? So how computer software determine these images are identical? They are using the color histogram. How do you use the color histogram to compare these two image similarity or not similar? In our eyes, these two image are identical. But how do computer know these are similar? Using the color histogram. That's the use of color histogram in measuring the similarity. So what do you do to the color histogram? You can compare the color histogram between two. That's the simple answer. So you are comparing. Here you got a color histogram. Okay. And B, you also calculate the color histogram. Okay. So these are color histogram for image B. And these are color histogram for image A. Can you, based on the color histogram, okay, can you see, are these two color histograms similar or not? They seem are similar. So when you got similar, that means the two images are similar. Because the computer couldn't understand what is the content. So if you see this image, this color histogram, and this color histogram, the pattern are almost similar, then computer can make conclusion that these two images are similar simply because the color histogram of image A are similar to color histogram of image B. Okay, the same thing. And again, how do you measure these two X-ray of, this is the X-ray of lungs. So how do you, again, the same question, how computer to decide whether these two images are similar? They are using color histogram. And what they do to the color histogram, they just compare it, the color histogram. So the same thing here. So you got color histogram here. So in other words, like this. Okay. Now you got the color histogram of this. Okay. So both this color histogram of this and this is color histogram of this. You just simply comparing the color histogram between two. How do you compare basically this and this? So from what we see, this color histogram and this color histogram are similar pattern. So we can decide these two images are similar. But how do you compare this and this? Anyone? How do you compare this histogram of A and histogram of B, image B? So how do you compare? By eyes, it looks similar. But in problem-solving computer, we need to find something to make sure this is similar. Count the gradient. Okay, good try. And who else? How do you compare this and this are similar using a computer? We have to instruct the computer to check. So what do? This is problem solving, you know. You got two color histogram. How do you compare this color histogram are similar to each other? Count the gradient. Good. Any more? That's the good thinking. You can count the gradient of the line, isn't it? Almost similar or not. Compare the luminance. Okay. Good. Any more? This is rational thinking actually. Not really. You don't need any specific knowledge or whatever. Look at the color histogram there. So how do you compare color histogram between two histogram? This is color histogram. Say I got another one here, color histogram. So how do you compare between these two? Now look. You call it, this is a bin. You compare bin by bin. Bin 0. You got 3. Go this histogram, bin 0. 3. Fine, good. It's similar. Bin number 1, which is 1. And then compare to bin this one. Compare this bin number 1 and bin number 1 of A and bin number 1 of B. So it is the same. If you got bin number 2, 0, 1, 2. Okay. you also have to compare this bin, and so on. This is 0, 1, 2, 0, 1, 2, 3. Bin number 3. You have to measure bin number 3. Okay, so that means you compare like this. Okay. So, okay. All right. And this is color histogram what we see. In computer, you just simply can store in the array. Okay. On array. Normally they store it in array. Okay. Bin number 0, bin number 1, bin number 2, bin number 3. This is A. Bin number 0, 3. Bin number 1, 1. Bin number 3, number 0, 1, 2. Bin number 2, 1.5. Something like, for example, put 2, easy. Bin number 3, 4. Okay, so this is for A. For B, you can have this similar array. Okay, so again, this is bin number 0, bin number 1, bin number 2, and bin number 3. Okay, look here, bin number 0, 3. Bin number 1, 1. Bin number 3, 1, 2, 3, 2. Bin number 3. So this is basically 2. Alright? So you can compare between these two. These 3 and 3. Okay? Similar. 1 and 1. Okay? The same numbers. 2 and 2. And this is 4 and this is 2. This is a bit different. Okay? Pixel bin number 3 contain 4 pixel, but image B bin number 3 contain 2 pixels. So this is a bit different. The rest is the same. When 1 pixel is different, you can also say it is a similar because this one different, you know. These 3 are the same. And it's just like this one, okay? Okay, that's basically how do you measure these two are similar. You just comparing the bin. Remember the word bin here. Okay. So when I said bins, basically is this one. This number bin. How many? 254 bin. When you comparing between bins, that means distant. Okay, distant. So you normally read somewhere or heard about the word distant. Distant. Okay, the distance between two image. The distance. Distance means just this and this. How much different? This is bin number 0. This is bin number 0. Okay, this is image A. This is image B. So the distance, if you got here 4 and here you got 3, so the distance is quite small, okay? If you got 4 here, the distance is 0 because 4 and 4 are similar, simply like that. Okay, that's the distance. Okay, so this is bin number 1. This is bin number 1. So this one and this one, the distance are quite big, you know, because this is almost half. And almost all of this between A and B, the distance are quite big. So I can see these two, image A and image B, are not similar. Because bin number 0 mean the first color. The first color, whatever the color it is. So it's different. Color number 2, bin number 1. bin number 1. Okay. So the pixel are different. So the distance is quite far. So this one, the distance quite far. So this and this are quite far. So we don't see the images, but we know that from this color histogram, the image are not similar. Okay, can you got it, everyone? So it's just simply you're gonna use how to solve the problem. Given the two images like this, how do you compare the similarity between this image? Just and compare one by one. And so that is research, you know. You come to this detail, then you figure out how do you compare this histogram A and histogram B. So in problem solving, you can say the first bin minus this bin, the first bin minus this bin, the first bin minus this bin, the first one minus this one minus this one, and this one minus to this bin, and this one minus to the same bin here. You can cut it minus. All right, when you minus, so you got numbers. So from that numbers, how do you make a cut-off line that when is the histogram supposed to be same and when the histogram not to be the same? You can say it in percentage. If the difference between this and this, say less than 10%, is similar, the same like this. If the difference is only less than 10%, it could be similar. More than that, it's not similar. At the end of the day, you can say if the number of similar is bigger than the number of not similar, then we can conclude the image are similar images. All right. There is two things here. Another one you learn about color histogram. Another one is about problem solving. Okay. So the question is, how do you measure the similarity between two histograms? To say that two histograms are similar or not similar. So there is various sort of way to measure, and that's why you have to go to the literature survey. How they measure the same, how they measure the distance between two metric, between the two color histogram. If you write Google how they measure the distance between two color histogram, you can come out like this. So people come out with various way. Okay. So that's how you calculate whether two images are similar or not, by having the distance between two color histogram. So you can talk about this in just one chapter, you know. Huh? You can say any whatever distance, you know. Or probably you have come out idea of cumulative distance, group distance. You grouping this one, then you group this one, take the average. You group this one, you take the average, and you can compare the bin. You can do that. And at the end of the day, you have to look the real color. The ground truth is, this is the ground truth. The ground truth is, when we looking by our eyes, I'm looking by my eyes, I see this is similar images. I see this is images that has the same category, which is the chest X-ray. So these both are similar, which is consider both pictures are chest X-ray. That's the ground truth. The experiment is this one. When they said similar, when you calculate the distance between these two, and you conclude that this is similar, the prediction is similar, then you have to look at the ground truth. The ground truth here is similar. Then your accuracy is right. Make a good prediction. Okay. All right. Well, everyone. Okay. Did you got it? Okay. Then in research, you have to come out with some certain formula just to make it good. Okay, compact and define. So this is a color histogram of the first one, and this is color histogram of the second. You got minus, and then you accumulate total up. Alright? In other words, these formula are basically the summary of what I'm saying just now. I can talk about this similarity in writing in one page. Then at the end of the day, I just summarize my explanation using one formula. Alright? So these formula are self-explanatory. This one single you can describe in 1 or 2 pages by writing. Alright? So these formula are powerful. So that's it to define the way everybody can understand clearly. Alright, and so this thing like this, okay? You got two, so this is the summary, okay? You got 2 image, alright, and then you see that these 2 image are the color histogram of A and B are similar. So the color histogram is similar. When the color histogram is similar, you can say that these 2 image A and B are similar. In this case, you see it, but if you don't see the image, then you can say that this is 2 similar images. Alright. So the distance is 0 basically. I can say, you know, if you minus bin this and if you minus this and this, the distance will be 0. Okay. Is this a good idea or not? So what are the weaknesses? Anyone know? Thinking a bit further up. If I compare like this, histogram A and histogram B, and if the distance is smaller, I can conclude that this A and B are similar image. Any weaknesses this approach? Anyone that you can think of? The weaknesses of the approach when you comparing each bin by bin, the distance of bin by bin. A little bit further thinking. Anyone can come out with the weaknesses? Anyone? This is what we can think about the weaknesses. Okay, you got 0, you got 0, you got 0, and 1. Okay, now you plot the color histogram. 1, 2, 3, and 4. Okay, and you got 0 and 1. This is the color. 0, you got 3, isn't it? 3 there. Okay, fine. 1, got 1 there. Okay, now if I got like this is I want to talk about the rotation, you know. Mr. Jinwei talk about rotation. Alright, so if I put here 0, 0, 0, and 1, you will gonna have the color histogram. So 1, 2, 3, and 4. Okay, 0, 0 is 3. 1 is only 1. Alright, so this is image A, image B. Alright, the color histogram, this one and this one, 100% the same. The distance is 0. The distance between this and this are 0. Because they got 3, 0. This one and this one, the distance is 0. Because it is 1 and then this is 1. It's the same thing. There is no distance at all. It's exactly the same. So the distance also 0. It is a perfect match for saying that these 2 color histograms are 100% similar. These 2 color histograms, A and B, are 100% similar in every aspect. But when you see the image, it's going to be different here. Alright? So this basically simply like, and these are simply, alright? So you see, this and this, when you do, this is a rotation of this one. See? This like this, when you rotate, it's simply like this, but it is still a similar images, isn't it? Yes or no? If you look at this image and this one, they are similar because this is just you rotate, probably, or you flip. You flip like that. This is like this, and this is you just flip. Okay, when you flip, the same image you flip, it contains the same. So in this case, it still looks similar, isn't it? But what if like this? 3 by 3, 1 bit. Okay. Now draw the color histogram of this one. So now you have 0 and 1, isn't it? How many 0? 1, 2, 3, 4, 5. 5. How many 1? 1, 2, 3, 4. Okay. Now look at this one. The same image. Okay. Draw the color histogram. So let's put this 0. Okay. Similar like that. Okay. So you got 0 how many? 1, 2, 3, 4, 5. You got 5. And how many you got? 1, 1, 2, 3, 4. You see the weaknesses of this approach? Comparing the color histogram for similarity of the image. If the histogram are similar, so the image are similar. Anyone see what I see? Yes or no? So this image basically gonna be let 1 is black, is red. So this is like a checker, you know. So this is the image. Okay. So 1, 2, 3, 4. 1, 2, 3, 4. So the bit pixel 0, 0, 0, 0, 0, 5. So you got 0, 5. 1, 2, 3, 4, 5. And you got 1, 4. 1, 2, 3, 4. And in this case, okay, 0 is what? 0 is white. 1 is black. So black here. Okay. Now, you see the color histogram. This and this. The color histogram this and this. They are 100% similar. Exactly the same. You got 0 is 5. You got 1 is 4. And this color histogram, the bin 0 you got 5 and the bin number 1 you got 4. Color 0 you got 5 pixel. Color black black you got 4 pixel. Here white you got 5 pixel and black you got 4 pixel. So this and this are 100% the same. So when the color histogram of both are 100% the same, will be definitely they are the similar photo. But actually they are not. See this one. Okay. So this is the weaknesses. You understand or not, everyone? So this will become your problem statement. In chapter 1, you're going to be a problem statement. You have highlighted the weaknesses of the current technique by giving the example. Then after that, you're going to think again, how do you eliminate this one? Because you can say the same color histogram, the 100% similar two color histogram, not necessarily both are the similar images. Okay, got it? What I mean?
Yes, doctor.
Understand? So that's the way you do your when you do the thesis later on. You're thinking something like this. This is what you have to find, the weaknesses, and then you can talk about this is when describing this. You can the problem statement. You can have 2 pages. And how do you solve this one? Then come out to your proposed work. You have to think about something. How to make sure that even the color histogram are similar. How do you want to check this? All right. Okay. So, and again, and this year, two color histogram are similar. Fine. First step, we can conclude that the 2 photos are similar. But now, wait. We have to check this one. If this is, we check this one and pass, then we can say, okay, that's similar. If we didn't check this one, we cannot really say the 2 colors, the 2 histogram that has similar pattern would be the same image. Then in your case, what technique do you use to compare these 2 images will be the title of your thesis. Okay? The technique to check this one on top of similar color histogram. So this is going to be your proposed idea and going to be the title of your thesis. You can name anything that you think it is similar to what you propose at hand. Or probably, I think, probably some of you thinking, you will put this overlapping here. Or probably you use a filter, whatever. I don't know. Okay, it's up to you because filter can move one bit to another bit. You see, a filter is a good approach here. To check whether these 2 patterns are the same, you use filter. Because when you use filter, this filter and this filter will be not the same. Isn't it? Yeah. You can use filter. Filter base and something like that, okay? Okay? I think filter can be used here just to check this one. Let's move to the other one. Okay. So another one of color histogram, basically on image retrieval. We're going to use sub-pattern match. Sub-pattern match, okay? So this is to show how color histogram can be used as an image to measure the similarity of 2 images using color histogram. We're still using the distance here. Now the sub-pattern match. Okay. So you can think about dividing the image into a few components. Okay. You can have an image like this. Instead of you comparing the whole image, so the whole image you got color histogram, but you can crop just this picture and get the color histogram. Okay, get the color histogram of only this portion, isn't it? So at the end of the day, you can have like this, for example. Okay, so each of these got color histogram. This you got color histogram. This you got also color histogram. And this you got each color histogram. You can do like this as well. And this you have color histogram. Alright. So you got 4 color histogram in this case. Instead of the whole, you can produce color histogram. You also can divide the image into 4 components like this, and each of these has color histogram. And in this case, you divided the image into 4 components. Or you can divided the image to different. So that 4 component, you also can divide it up to you. Okay. So in this case, you got 6 color histogram. Okay. And here you also got color histogram. Then when you comparing, you can compare this and this, this and this, this and this, and so on until the last one. Okay. So this also you can apply to this one. Okay. This one. Okay. So you divided whether it is the same or not. So at least you can focus a little bit more detail on comparing two images. Okay. So you have each. It's up to you. So this up to you to how many components you want to divide it. And in this case, the similarity measure a little bit more detail. Then you take the whole thing. And this can make the accuracy more accurate. Okay.